Have you ever looked at a river and wondered how it got there? Or how it can carve out massive canyons or build up huge flat plains? Well, today we're going to follow a river on its incredible journey, all the way from a tiny mountain stream to the wide open sea. We'll see how this amazing force of nature is both a master sculptor and a grand architect of our world. So here's the plan for our trip. First, we'll look at the two basic forces that give a river its power. Then, we'll follow the water through its wild, early days in the upper course, see how it matures and starts to wander in the middle course, and finally, watch as it builds new land in the lower course. Let's get going. Okay, so let's jump right in. To really get how a river makes anything, you have to understand that it's basically doing two opposite things all the time. Think of it like a constant battle between a carver and a builder. Right. On one side, you've got erosion. That's the carver. It's the process of the river wearing down and carrying away bits of rock and soil. And on the other side, you've got deposition. That's the builder. This happens when the river starts to lose energy and just drops all the stuff it was carrying. Literally, every single landform we're going to see is created by this constant push and pull. Our journey starts way up high in the mountains, in what we call the upper course. Up here, the river is young, it's fast, and the slope is really steep. It's just bursting with energy, and its number one job is to carve straight down, cutting into the landscape with some serious force. And the very first spectacular thing this powerful young river creates is something we've all seen pictures of. But what exactly is a waterfall? Simply put, it's just a vertical drop. It's where the riverbed suddenly changes slope, almost like a giant step in the middle of the river. So how does that step even form? Well, it all comes down to the rock underneath. Picture a river flowing over a layer of really tough, hard rock that's sitting on top of some weaker, softer rock. The water hammers away at that soft rock much faster, carving out a deep pool at the bottom called a plunge pool. The sheer force of the water and all the rocks it's carrying act like sandpaper, digging that pool deeper and deeper and undercutting the hard rock above. Eventually, that hard rock ledge is left with no support, and it collapses. This whole process just repeats over and over, which actually makes the waterfall slowly move backward, upstream. Now, as that waterfall carves its way backward over thousands and thousands of years, it doesn't just vanish, it leaves something absolutely incredible in its path. A gorge. This is a super deep, narrow valley with these incredibly steep sides. You can always spot a gorge because of the fast-moving water and all the giant boulders you see in the river. Yep, those are the leftover pieces from all those collapsed overhangs of the waterfall. But this powerful downward cutting doesn't stop with gorges. It actually shapes the entire valley in a really specific way. With all its energy focused on carving down, the river creates that classic V-shaped valley. But when it's this young, it's not quite strong enough to just blast through the hard hillsides, which we call spurs. So instead, it has to wind its way around them. And when you look down the valley, these hillsides look like they fit together, kind of like the teeth on a giant zipper. We call those interlocking spurs. The last feature we'll see up here in the upper course is rapids. You can kind of think of them as mini waterfalls turned on their side. They happen when the river flows over bumpy ground, with bands of hard rock that don't wear away as easily. These bumps in the riverbed make the water all choppy and turbulent and super fast. Okay, let's head downstream a bit and see what happens next. As we get to the middle course, the land starts to flatten out. The river loses some of that power to cut straight down, so it starts using its energy to cut sideways, making the valley wider. And all this sideways erosion creates the number one feature of the middle course, a meander. It's really just a fancy word for a big winding bend in the river. So how does a meander even work? Well, it's a tale of two different speeds. On the outside of the bend, the water has to travel a longer distance, so it speeds up. It's like the fast lane. This speedy, powerful water erodes the bank, carving out a steep little cliff. But on the inside of the bend, the water has a shorter trip, so it slows right down. It loses energy and drops all the sand and gravel it's carrying, which builds up a gentle, sloping beach called a slip-off slope. So you have this process, eroding the outside, building up the inside, that makes the meander band get bigger and wider, more and more C-shaped over time. But what happens when that C-shape gets a little too extreme? Well, as the meander grows, that little strip of land between the two bends, the neck, gets thinner and thinner. Then, one day, a big flood happens. And the river, which is always looking for the easiest way to go, just smashes right through that narrow neck of land. It creates a new, straighter shortcut for itself. And over time, the river drops sediment and plugs up the entrances to the old C-shaped bend, leaving it totally cut off as a beautiful, curved oxbow lake. All right, we've made it to the last leg of our journey, the lower course. Down here, the river is wide, it's deep, and it's moving really slow. Its main job isn't eroding anymore. Now it's all about depositing the huge amount of sediment it's been carrying all the way from the mountains. This is where the river truly becomes a builder. The biggest thing you'll see here is the floodplain. That's the super wide, flat area of land on either side of the river. This really fertile ground is built up over hundreds of years, layer by tiny layer, from all the fine mud and silt that the river drops every single time it floods. And right on the edge of that floodplain, you'll find levees. These are like raised banks right along the river's edge. They're actually built by the river itself. During a flood, as soon as the water spills over the banks, it loses energy and drops all its heaviest rocks and pebbles first. After many floods, this stuff builds up into these natural walls that help keep the river in its channel. And finally, our river reaches the sea at its mouth, in a place we call an estuary. This is where the river's fresh water mixes with the salty ocean tides, and the current slows almost to a stop. With pretty much all its energy gone, it drops the very last, finest bits of sediment it's been carrying, creating these huge, wide mudflats. The river's journey is finally over. So, from a tiny mountain stream all the way to the open ocean, we've seen how a river is always at work. Let's do a quick recap of everything we saw get created on this trip. And this table just lays out the whole story perfectly. Up in the upper course, it's all about pure, powerful erosion, which gives us waterfalls, gorges, and V-shaped valleys. Then in the middle course, it's that balance of erosion and deposition that creates meanders and then oxbow lakes. And finally, in the lower course, deposition takes over completely, building up floodplains, levees, and estuaries. So from carving rock to carrying silt to building land, it's all part of this constant, beautiful cycle. And it really makes you think, right? If a river can do all this, if its job is to literally shape the world, what does that tell us about the incredible power of small, steady actions repeated over a very, very long time?